Hi learners, welcome to my channel. Today let's discuss and learn law of conservation of linear momentum. Okay, what is conservation? There is no waste. Okay, so linear momentum, body is moving in a straight line. It has momentum. What is the formula for momentum? Momentum is P is equal to mass into velocity. Okay, so this law states that there is no change in the linear momentum of a system of bodies as long as no net external force acts on them. So there is no change in the linear momentum. So momentum P is equal to mass into velocity of the body. Okay. So when two bodies are moving in a straight line, the momentum is conserved. That is, momentum before collision is equal to momentum after collision. What is the condition? This will be satisfied only when there is no net external force acting on them. So come again, the law states that there is no change in the linear momentum of a system of bodies as long as no net external force acts on them. Okay. Let's move on to the proof. See, you consider two bodies, body A and B. So this is one body A and this is another body B. This body A having mass m1 and body B has mass m2. They are moving in a straight line. Okay, so in this direction, both the bodies are moving. This body is moving with the velocity u1 and this body is moving with the velocity u2. Okay, so for our convenience, let's assume u1 is greater than u2. That is, velocity of the first body is higher than the velocity of the second body. That is, this body is moving very speedily than this body. Okay, this body speed is slow, whereas this body's speed is high. So what happens after a time t? This will dash this body. Yes or no? This dashing, you call it as collision. They are hitting each other, isn't it? So look at this diagram. They are hitting each other. So this you call it as collision. When there is collision, body A hits body B, and therefore due to Newton's third law of motion, this body B will exert some force, and that force B is Fb. Okay, so they are acting in different bodies. So Fa acts on B and Fb acts on A. Any doubt in this? Okay, so after some interval of time, they tend to collide. That is, they are dashing because this body is moving very speedily, whereas this is very slow, isn't it? So after some time of a time t, they will hit each other. So let time interval, let it be t seconds. So after impact, after collision, what happens? Both of them move along the same straight line with the velocity v1 and v2 for A and B respectively. You see, after hitting, what happens? Both are moving again in a straight line. Okay, same direction they are moving, but what happens? They will not be with this velocity. So velocity will vary, isn't it, after collision? So this velocity is initial, whereas the final velocity of body A is v1 and final velocity of body B is v2. Now let's move on to the derivation part. So what is that? So when force is applied or when force is exchanged due to collision, force on body B due to A. So this body A is hitting body B, isn't it? So it is giving a force. So force on body B due to A is Fa is equal to second body, isn't it? So it is m2 mass of the second body into what is acceleration? Force formula is force is equal to mass into acceleration. Again, acceleration is change in velocity by time. So since it is second body, so it is v2 minus u2 divided by t. Therefore, Fa is equal to m2 into v2 minus u2 divided by t. Any doubt? Okay, similarly, you see force on body A due to B. So after hitting, what happens? Body B also will give some force on body A, isn't it? So for example, you consider a carom board striker. So when carom board striker, when you hit one coin, what happens? It will go and hit the coin. When the striker hits the coin, what happens? The force exchange takes place. Okay, so striker exerts a force on the coin and coin exerts a opposing force on the striker. That's why in carom board the striker comes to rest after hitting a coin. Okay, that is for day-to-day explanation. Okay, so force on body A due to B is force B is equal to this force is exerted on first body, isn't it? So first body's mass is m1, velocity is v1, initial velocity is u1 divided by t. Therefore, force on body A due to B is Fb is equal to m1 into v1 minus u1 divided by t. So Fa you got, Fb you got. Now you got two forces by Newton's third law of motion. What is Newton's third law of motion? For every action, there is an equal and opposite reaction, isn't it? So, action force is equal to reaction force. What is action force? Body A is hitting body B. So, what is reaction force? Body B also will exert some force on body A. Okay. So, FB is equal to minus of FA because both are acting in opposite direction. Look at the diagram. The force acts in the opposite direction. Okay. Now let's substitute for FB and FA. For FB, what is that? It is M1 into V1 minus U1 divided by T, which is equal to minus of what is FA? M2 into V2 minus U2 divided by T. T and T, they are in the denominator. So it gets cancelled. Okay, so at the same time, so m1 into v1 minus u1 is equal to minus m2 into v2 minus u2. Now let's remove the bracket. What happens? m1 into v1 is m1 v1 minus m1 into u1, which is equal to minus m2 into v2. Minus of minus is plus. So, plus m2 into u2. Any doubt? Now, let's bring all v component one side and u component the other side. What is this? Final velocity and this is initial velocity. Collect it. So, what happens? You see m1 v1. Here it is minus m2 v2. When it goes to the other side, it is plus m2 into v2, which is equal to this goes the other side. So what happens? M1 into U1 plus M2 into U2. When you find this, it is nothing but the net momentum after collision. Okay. So net momentum after collision is equal to net momentum before collision. Hence, the law of conservation of linear momentum is proved. Why? So, in the absence of external force, the algebraic sum of the momentum after collision is numerically equal to the sum of the momentum before collision. That is what law of conservation of linear momentum says, isn't it? So what does the law say? The law states there is no change in the linear momentum of a system of bodies as long as there is no net external force acts on them. That is, nobody is hitting this ball, isn't it? So this ball, due to its higher velocity, goes and hits the second ball. So nobody is forcing this ball. Automatically it goes and hits. So no net external force is acting on them. What happens? Net momentum after collision is equal to net momentum before collision, and this is the final equation. Okay. Okay learners, if you are new to my channel, please do subscribe. Many videos, teaching videos will be on my channel soon. So please do subscribe, make use of it. Thank you. Bye-bye. I'm Judy.